Hello, good morning, good evening, good afternoon, and welcome to Going Meta episode 25 today. Out of the darkness, I'm talking to you. It looks like it's a bit
I
weird.
was
Yeah,
I was gonna say, Alex, you're an
yeah,
unusually dark background.
I'm, yeah, it's a little bit weird. I'm in this hotel room and they have like this corner space for the desk that is here, and there is no lamp except for this one here at the desk, and beneath me rather is the rest of the room, and it seems like, I mean, lights are on, but it's looking it's a bit weird. But I'm here in Stockholm this week for JFocus, which happens tomorrow and on Wednesday. So that's why a different location. But yeah, I just realized earlier, but I couldn't do anything about it. So there is no.
I know. Don't worry, we can see you very well, and we
Yeah.
can hear you very well. So it's all good.
It's great. It's great to have you all join. I saw a lot of people already before we actually, went live. Talked to a few people from shared where they're from and what they watch from Amsterdam, from New Jersey, from North Carolina, from other locations, New Hampshire here. So it's great just to have you all here. Even for some of you, it must be a little bit early in the day. For some of you, a little bit later here in Europe. For sure, or even in Asia, it's very late. So if you're watching this live, as always, it's great to have you. It's great to have your comments, your feedback, your insights. And yes, Walter, it looks like Harry Potter room under the stairs. I get the feeling. I know now. I know how Harry Potter must have felt. It is almost as narrow and as good. My bed is a little bit bigger, so for at least I don't have to sleep here. But yes, it is exactly that room. Today's topic is LLMs for automated knowledge graph construction. So this continues a little bit our journey of LLMs, RAG, knowledge graph,
That's
bundle of topics that we discussed since I think episode 21 or so. Not necessarily you have to watch them all in order, or have watched everything before when you watch now, but they kind of, I think, connect well with each other,
yeah.
and build
I,
upon each other a little bit.
I actually think that
Yeah,
they kind of make sense. I mean, it kind of they sort of build somehow on top of each other,
yeah,
and I
yeah,
mean, of course, if you're familiar with some of these topics, of course, you can jump straight on any of them. But I think if you're on a learning journey and how what the value of the combination of knowledge graphs with LLMs is, I think it makes sense to watch them in order. And you're right, Alex. I mean, today we are kind of staying in the topic of Gen AI, but stepping a little bit out of RAG. I mean, we've been doing RAG for the last 2-3 sessions. So today we're still going to be using LLMs, but this time to help in the construction of the knowledge graph, right? And in particular, we're going to be looking at how to do that from this time from structured data. So we've
mhm,
been seeing a lot of interest in okay, I have unstructured data, I can do entity extraction and populate the knowledge graph. What we're going to be looking at today is, okay, I have some structured data, and that can come from a relational database, from a collection of CSV files. So what do I do with these, and how do I build the graph out of that? So that's going to be the topic of today, and we're going to see how LLMs do actually help.
yeah. Sounds good. And I guess, correct me if I'm wrong, but I think today's topic was a little bit influenced by a comment we received on YouTube.
Absolutely. You're going to see that in
Yeah.
in the first 2 slides, because I'm going
All
I'm
right.
going to spend a couple of minutes, and you're going to immediately recognize it. That's right. I mean, there's a couple of reasons that brought us to run this session, and one of them is exactly people's comments and people's suggestions, which actually it's a great segue to say, please keep coming to us and keep telling
Yep.
us the things that are not clear, that you want us to go deeper in, and that will help us coming up with new episodes and new experiments to run. So
Exactly. Yeah, that's what I wanted to say as well. If something isn't clear, obviously that's great. But if something else is on your mind, and you think, hey, wouldn't it be nice if Jesus were to discover this, or were to dive into this or that topic, then let us know, and we can see if that makes sense in one of upcoming episodes.
perfect. do we get
But if you don't
started?
have anything to suggest now, then you can hopefully you interact with us during the episode. So lots of people chatting already away. So that's great to see. Keep that going so we can make it a conversation rather than a monologue, even though we are two people.
Exactly. Oh, that's very interesting. Unable to share my screen, and that will be because I have obviously changed laptops. So Alex, you're gonna have to cover me for a couple of minutes. Why? Because I'm gonna have to change the settings and leave the meeting and rejoin. So
yep.
you're gonna have to come up with a few jokes. I'll be back.
All right, good.
See you in a minute.
See you in a minute. All right. So good. I'm not really good at jokes, so I hope you help me out here, dear watchers. Maybe somebody has a joke they can type in and I can read off on your. Maybe I should ask ChatGPT if he's got a graph joke, but usually they are super bad. But I can open that up just to keep going. Tell me a graph joke. Let's see what he says, or they. Why did the graph go to therapy? Because it had too many unresolved complexes and couldn't find its own limits. Oh, well, I'm not sure. Dad jokes, yeah, okay. Maybe I should ask. Make it more like a dad joke. Okay, another one. Why don't graphs ever go to parties? Because they always have too many points and can't connect the lines. I'm not sure. I mean, no. I think we have to cut this out. Well, I mean, until Jesus is back, I can only reiterate that the previous episodes are all in our repository with the code, but also all the videos you can find in our landing page. Whoopsie, where have I gone? Which I'll share in chat. So you can look there and find all these previous episodes we did since episode 1. Basically, and this is updated constantly. So following through to today's episode. So if you are ever wondering why, where to look at and how to find that, Emil wants to hear another touch. Okay, well, I mean, then I guess another one. If you if you can bear the pain. Another one here. What do you call a graph that's been lying on the beach too long? A tangent. I don't think ChatGPT understands jokes very well.
Oh man, you're gonna kill me. I'm back, but it's showing the same. How do you help center? Damn it. How did we? Maybe you.
Yeah.
Help me, Windows user, Max user. Only have. Well, I'm willing to take tips here because I'm.
What did you do? Did you let the app
presentation to share? If I share entire screen and I select the screen and I click share, it's still showing update system permissions, but which permission is that? Because I thought I had.
I think on the Mac you need to switch it on and
and privacy maybe. Here we go. So camera.
But maybe
look at the comments. Oh my goodness, we're gonna get fired today.
we are getting.
Well, can we have our CEO helping us changing the settings so that we can share a bloody screen? Oh my gosh, that's embarrassing.
Can you share a window instead? Does that work? Did you try?
I can try, but I believe. Oh, yeah, that's a good point. Good. Let me. So if
the last joke, at least. I mean,
share.
It's good. Yeah, that works.
Did that work? Wow. There you go. Perfect. Well, Good. Okay, well, that's great because that's all going to work from a single browser window. So, well, you can see it. That's great. What if I go on full screen on slideshow? Is it still showing nicely?
Yes.
Perfect. Okay. Good. Brilliant. So, right. So, like we're saying, wow, that's unexpected. Anyway, so yeah, well, like we were saying, we're going to be focusing today, staying, within Gen AI and using LLMs, but this time instead of to brag is to help us building a knowledge graph, right? So, and in particular from structured data. So, I said that it's kind of we're kind of revisiting what we did in Going Meta episode 5. That's many months ago. But what we did back then is we had some structured data in the form of CSV files, and we have a kind of a target model defined by an ontology, right? So we know the kind of graph that we want to build, and we define some mappings, and then some kind of general purpose code, some Python code, basically would read that target model, would read the mappings, and generate the data ingestion pipeline to populate the graph. So that's what we did back then, right? There were some questions though, and that's probably where you were going, Alex. But at the origin of this was, of course, episode 5, but also something that Dan posted, a few weeks now ago, and Dan, if you're not following him, you should be, because he's great and he's doing amazing stuff also in the Gen AI space. And one of the things that he talked about, and this was, like I say, 2-3 weeks ago, was that he was trying to use LLMs to kind of help in the construction of a knowledge graph, right? Or the creation of the graph model. He focused on that, and I'm going to show in a minute. I mean, you have the link there to his LinkedIn profile, because he, like I say, he posts super interesting stuff, but also his GitHub account, where you can see his experiments. And actually, I probably have it here. And what he did, basically, you have the notebook. You can play yourselves. And he went and looked at the structure of a CSV file. He's using some, I think, insurance, public data, or government data around insurance. And he analyzes like the headers. He even does some profiling of the minimum maximum values, and using that he kind of interacts with an LLM to come up with a graph model. So that's one approach. What I'm going to do today is slightly different, but it's along the same lines. So it's also answering to these questions that you were mentioning before, Alex, where some people actually at the end of this episode 5, where we did what I described a minute ago, it was something like, hey, give me best practices around the modeling, because you start with the target model. What if I don't know how to build that model? How do I create this kind of declarative schema definition of the model, of the graph that I want to build? So these two things are the kind of the reasons that made me explore these idea that we're working on today. So
yeah, and I think we got in last or previous episode, we also got a comment on, hey, how can I use LLMs to model my knowledge graph? So it's not exactly the same topic we talked today, but it goes into I would say it goes in a similar direction.
Kind of, it's kind of similar. And these diagram shows the process. I mean, if you follow the numbers, and I tried to pick a common or popular source of structured data, CSV data mostly, which is Kaggle. And you will see that most of the pages, and we're going to see that in a minute, offer access, of course, to the data, some very rich description of the structure of the data, some metadata describing which are the key features in the data set, some description of the data set itself, etc. And that can be extracted in a structured fashion. That was a nice surprise, and I'm going to talk more about that. So you can extract both the metadata and the data itself, right, in the form of CSVs. I'm focusing on CSV data here. So what we're going to be looking at is, okay, I'm going to use LLM, and in this case, we're going to use again OpenAI to generate a data ingestion pipeline, which is basically a collection of CSV scripts that will consume the data. But this process is going to be fully automated. So I'm going to, at the high level, although I'll go into the details in the session today, I'm going to go and read the metadata description, right? A formal description of what's the structure of my data set. I'm going to pass that in a consumable format to the LLM with some prompt engineering there, and I'm going to ask the LLM to generate a model, a target model. So I'm not going to pass the model. I'm going to ask the LLM, hey, there's some latent entities, because the thing is, in these CSV files, sometimes you might find them very highly normalized, or you have a lot of help already. Let's say you have it broken down into files in the form of kind of a relational database, where you would have a file for customers, a file for products, a file for orders. You kind of have a kind of the model there, right? If you read the files, but sometimes you have a large CSV file, completely denormalized, and all you have is header descriptions, and you have to go there and say, hey, actually these 3 columns are one entity, and these 3 columns are another entity, and this is another entity, and so on and so forth. So this is something that you can do if you have some experience, but this is something that LLMs can help us with, and that's exactly what we're going to be experimenting. We're going to pass this metadata description. The LLM is going to come up with the model and the mapping, and then we're going to fully automate the process of, okay, now I'm going to read the CSV and I'm going to populate the graph. So that's what we're going to do. So step 1 is extraction of the metadata, generation of the model and the mapping, and third, importing the actual data. Make sense?
Yeah, that
so
should be fun.
I'm not giving any kind of guidance. The guidance will be in the metadata about the data set, and the LLM will do the rest. So the first surprise that I was mentioning, I was not aware of this. It's called a croissant format, right? That's something I hadn't seen before. But if you go to any data set in Kaggle, you will see that when you you can download the data itself, but there's also the option of exporting the metadata as croissant. I mean, a croissant is a JSON format. You see an excerpt there on the right. That actually it's a very rich and formal description of what the dataset contains, and the dataset will have a collection of record sets, and the records will have fields, and the fields will have a name, they will have some description, etc., etc. It's a very rich description, and interestingly, it's JSON, actually JSON LD, which, as we know, and those of you who have been following, JSON LD is a graph format, so we can easily import it. And that's what we're going to do, because once we have that description, we're going to be able to use that to create a prompt that the LLM will be able to consume. So first, a nice surprise is this croissant format. I put the GitHub repo there because it's being developed by the ML Commons body, and that's what it looks like. We'll see more of it in a minute. Now, once we have that, we're going to pass that. I mean, not exactly that, but in a nicer form of that to the LLM, so that it can generate a description of the model that ultimately is going to be our graph model, right? But we're going to have it in a form that we can consume in a machine readable format, and it will be basically a collection of entities, which is in Neo4j terms, the labels, the types of nodes that we're going to have, and for each of the entities, the entity types, and the list of attributes or properties, and then we're going to map them to the elements in the file. So this is all going to be worked out by the LLM. So the LLM is going to go over all the features in the dataset and will determine which latent or kind of hidden entities are there, and that's what we're going to use. When we have that, we're going to write some Python, like we saw, that's going to do the whole work of generating the graph model. Very simple. So in terms of interaction with the OpenAI API, we're going to be generating a prompt that looks pretty much like what you see there. So I'm passing the description of the dataset, the name, and the features in a readable format, and I'm going to use the completions API for it to generate a collection of entities and relationships, which is our graph model. So we'll get to see these in detail. Does that make sense, Alex? Any questions? Do we have anything there that we need to make clear before we actually get to see it in action?
No, I think that is pretty clear. I'm excited to see it in action. So I think we can go there.
Perfect. So I assume you still can see all the tabs in my notebook.
See all the tabs.
Browser.
Yes.
I'm going to connect. I'm going to work as usual in a notebook, in a Python notebook. And while we talk, I'm going to.
I think we have to zoom in a little bit in this view.
Yeah, let's do that.
Yeah.
Is it better?
A little more, maybe, if possible.
More? Okay, let's do that.
Yeah, and then I can do that.
Perfect.
Yeah, I think that's good. Yeah.
So the first data set that we're going to use is this New York housing market. This is a pretty simple data set, but as you can see, we have the human readable version of it. This is in Kaggle, and it's a single CSV file. I'm working with this type of denormalized structures. You could do with others, but for this example, I'm going to go with this. And we have a description of all the columns there. So you see that there is a description about the property, there's description about the address, there's description about it looks like there's a broker involved in this housing market. So it looks like there could be several entities in this data set, but we'll let the LLM figure that out. So this is, like I say, the human readable version of the data set. But if you go up here, you can export the metadata as a croissant. And this is this rich format that I've shown a minute ago. And I'm going to show again so that you can see it. Probably by now, we've already finished doing the install. I'm going to set up my connections, but basically we have the source here. So the croissant, I've copied it to my, just for this example, and I'm going to show it to you here. So this is what it looks like. So like I said before, there's some header, some information about language, and some high-level information. But then we have
This is also a little bit small.
Also smaller. Let me make it bigger. Apologies about that.
Yeah.
So there you go. We have a data set that contains a rec set, which is a collection of fields. So we have, for each one of the fields that we saw in the more human readable, we see the broker title, which is the title of the broker, the type of the house, the price of the house, the beds, the number of bedrooms. So we see that they are all listed there. And they come with the description of the name of the column and some additional information. So this, like I say, is JSON-LD format, and as you know, JSON-LD can be imported. And I'm going to use today something that we have not talked about in quite a while. I'm working with Aura, right? So I have my Aura instance up and running. It's an empty database at the moment. So let me make sure. Just to make sure that I'm on the right instance. Count, and it's an empty database. Perfect. So, and if you remember, in Aura, we cannot use extensions at the moment, and that prevents us from using semantics, which would be our default option for importing RDF data in JSON-LD is one form of that. Now, what we're going to use is RDF lib Neo4j, which is kind of it's a project that we talked about in one of the episodes quite a while ago, but that has a new version, something that our professional services team has been working on, and that makes it really, really easy to work with RDF data and writing to Aura, because it works entirely on the client side. I mean, it just works using the Python driver and interacts with the database without having to install any extension. So the way it works, without going into too much detail, I'm going to click for it to run. I mean, I think I've set my database. I'm going to set my files. I have a couple of extra examples. If we have time, we'll go through a couple of them. And the first thing I'm going to do is, I'm going to have a look at this croissant description of my data set. So if I run this code, what this is going to do, what I'm doing essentially is I'm importing, the RDF lib Neo4j, and I'm creating a store configuration. I'll have to go quickly over that, otherwise we're gonna not have time to see the whole thing. But we'll get back to it. There's an episode, and maybe Alex, you can find it, but it's one of the early ones where we talked about how to import data into Aura, RDF data into Aura. But basically, we define some of the kind of the way in which want the RDF to be imported, and we want to basically ignore the namespaces. We want to batch the import, and we pass the configuration, the authentication configuration, which is my credentials that I have locally. Once I have it, what I'm doing basically, I parse my croissant file, and by parsing it, it automatically gets persisted in my Aura instance. So we've imported 179 triples, which is roughly what we had in that data set. You will notice that there is a kind of a temporary hack. I've commented it here, and that's because at the moment the current version of RDF lib Neo4j does not support JSON-LD. So what I have to do is I have to import it and then serialize it as turtle to be able to import it. This will not be the case in the new release. You will check, if you check in the issues, it's already been committed to the source, to the code base, and the moment the team decides to do a new release, it will be out there, and we can just get rid of this intermediate step. But anyway, we have now the
I put the link in the comments and in the video description. It was episode number 12 where we talked about importing RDF data into Aura.
And it's one of the labs projects. So now we've imported this description, the croissant description of our data set. So if I copy this query, it's going to make it possible for me to explore that in my Aura instance. So there you go. Let me that makes it a bit more readable. So what do we have here? So we have a data set, which is this orange node. I'm going to have to probably make it bigger.
Yeah, thank you.
Actually take all the state. There you go. So we have the I'm going to make it maybe a bit bigger. So that's the damn it. The problem with the browser when is that when we have multiple labels, it gets a bit confused. But anyway, so we have a node representing the data set, right? If I click on it, you see the oops. What's it not? There you go. So you see all the attributes to the right. Right. Let me make that a bit bigger. And so we have the description, the name, all the information that we had in human readable form. We have it already imported in the graph. And the data set has, in this case, a single, again, I'm going to make it bigger, a single record set. I'm going to reorganize that to make it a bit more understandable. But what we have is that this record set is a single one. Again, it's described in this collection of attributes. And then we have a number of fields. And for the fields, I'm going to show the, damn it, that's the problem. I mean, it just, because it has more labels, it just goes a bit crazy, the browser. But let me try it again. And now it's ignoring me. Anyway, well, we'll have to deal with that. So the visualization is not going to look great, but basically these are the fields. You see that there's a field connection, and the fields have the name and the data types. So they're connected to the data types. These are two fields that happen to be integers. You can see here 2 additional fields that happen to be floats, and then a bunch of them that are strings, text. And you see that for each of the fields, you have the name and so on and so forth, right? So we have it loaded in the graph. So we have a rich graph description of the data that we're going to be importing. Good. Now, we have that, and we can use that to generate a textual description to the LLM. And what we're going to do is we're going to pass a more readable version of it. And for that, we're going to be running this query. Let me show you what it does. It basically does the same, but it returns it in a tabular form. So it tells me the dataset name, that's the dataset description. And then for each of the features, each of the columns in the file, I give the name and the data type. That's all. And it produces a list with all the columns in my dataset. So I'm going to use that. And I'm going to run this query now so that you can see what it does. So it basically runs this query, and we've stored in this variable the name of the dataset, the description of the dataset, and the features. All this to create a prompt. And this is the one that I showed before. So I'm telling you're a data modeling expert, that you're capable to create an entity relationship model, which in this case is exactly what we need, collection of entities and collection of relationships. And I'm passing the 3 elements that I've just extracted from the graph. If I run this, you're going to see what it looks like. So there you go. So it just passes the name of the data set, a description, not very useful in this case, but sometimes they're richer, and then a collection of features, which is a list, kind of a collection of pairs, feature name, data type, feature name, data type, right? So that's what I'm passing, what I'm going to pass. This is the prompt that I'm going to be passing to the completions API. So if I run this, it's going to take a few seconds. But basically what we're asking the LLM is, yes, go explore this collection of features that are flattened in a single file and determine if there are recognizable entities. Basically, can you come up with a graph model for me? I don't want to do it. I want you to give me some guidance and give me some assistance in doing that. So it's done. And now we can print out the results. So we can see that it's come up with a plausible collection of entities. For example, there's a notion of a property. A property has a type, a price, a number of bathrooms, square feet, and so on and so forth. There's also the address. So it's decided to split into the entities, which kind of makes sense, right? Because they consider two different entities. And there's the notion of a broker.
Remember, it could be different properties at the same address.
Exactly. So we have three different types of entities, and then it's identified three relationships that connect these entities. So there's a connection has address between the property and the address, and the has broker between the property and the broker. So pretty nice job, right? So I think it's made a good interpretation of the data set, of the description, and we're going to go with that, right? All we need to do is okay, well, that's all the information I need, because I have the name of my of the fields or the features in my data set, which is this mapped to, and this is the name in my in the property in my model, and that's all. Like I say, that's all I need. So the next part, I'm going to run these. I might go in detail, but basically this is where I reuse the code from episode 5. This basically is generic code that is going to explore structure and generate cipher. So it's going to parse that, and it's going to create both the constraints, but also the data input, the cipher input, which basically are load CSV instructions that can out of this description. I'm going to show the result, and maybe it's just a bunch of lines, so it's not super complex, and but we're going to see what it looks like. So this is the definition of the function. I'm going to actually call it on the output of my of the LLM. I have to make sure, and here there is a caveat, because let's see if there are mechanisms to make sure that the output of the LLM is matches a particular schema, right? So sometimes it's generative AI, so it can be a bit creative, and it can come up. It can name properties in different ways. For example, sometimes in name, it will call it entity name, or it will call it relationship name, or instead of mapped to, it would call it mapped to feature. So there's ways of controlling that, and there's like function calling. There's Pythonic. There's a number of ways of doing it, but I didn't have time to prepare it, and it would have made a super long session. So what I've done is I've made my code flexible enough so that I can tune it depending on. But it looks like the names are pretty much the same that I was expecting. So there's a from, there's a to, there's a type. Mapped to is the same, and there's name for both names. So it looks like it's the the expected type of structure, but in case there was some variation, that would have helped me react to it.
Okay.
But essentially, what like I was saying, what this does, if I run it on the output of the LLM, it has produced the following output. Look at that. So it's generated, because there are three entities, we're going to be creating three constraints.
Nice.
So there's property, address, and broker. So this is valid cipher. This is the creation of the constraints. And at the same time, it's created a loader. Basically, it was going to load from this file, which is the one that we specified at the top. And we're going to be unwinding, because we're going to read the file, pass it, stream it to this code, and read record by record, which is what the unwind does, and create entities, create nodes of type property with the properties as defined. And you see that it's going to be reading them from the corresponding column in our dataset, because we had it in the mapping that the LLM has generated. So very similar, a bit simplified from what we did in episode 5, but that's pretty much all we need, right? So I have all the cipher that I need to ingest the model, to ingest the data, and create the model that the LLM has come up with. So, and the same for the relationships, and so on and so forth. So all I have to do is actually run this code. And that's what we do with this in this function. Again, you can have a look at it, but basically all it does is read I'm going to read the CSV file, and I'm going to batch the file and send it in chunks to the graph, so that it's persisted in Neo4j. So.
And the code is available afterwards.
Absolutely.
So we put it again in the repository.
Not right now, but it's going to be at the end of the session.
Soon. Yeah.
Absolutely. I'm going to go in a little bit of detail, but I wanted to kick it off just to see if it throw any errors or anything unexpected. There you go. So it's already, like I said, it's basically using pandas to read the CSV file. It's calling the insert data function, which is this one that we created here, that chunks the file in batches and sends it to Neo4j by running, execute the cipher that we've just created. So it takes the cipher and runs it and imports the data. So there you go. So it's imported the properties, the addresses, the brokers, is loading the relationships, and it looks like it's done, right? So we can now come here and explore. And yeah, we have, as expected, let's see, for example, we have the has address. Let's make this bigger, but no surprises. So we have properties that we can change slightly. Maybe we can refer to a property by I don't know, maybe we can put the type. It's and the properties are linked to addresses, and we might even find things like properties. There are multiple properties in the same address, right? So there can be a has address. Let's look at that. There you go. So it's done a good job, right? So it's transformed our original flat file, CSV file, that contained, well, you can explore it here. You can transform this flat file into a graph model and load it. And we had also, if I expand, we had also the broker, remember. So, I mean, it's worth saying that this is a fully automated process. So I kind of eyeballed the output, and this might not be a perfect model, but it's a great starting point to say, hey, I want to see my data as a graph, and I want to come up with a plausible model, a reasonably okay model. So that's what we've done. Does that make sense? Because you might say, of course, the question might be, well, this is a pretty simple model, and yeah, I agree. I mean, this is as usual. We try to kind of come up with kind of didactic examples, but we're going to just to show that it's a generalizable process. I thought, well, let's give it a try with another data set, because it's exactly the same code and it's entirely data driven. So what I'm going to do is I'm going to empty the database. So if I empty that, shouldn't take too long. It's just a few thousand nodes. There you go. So we're starting again, and we can actually, because we created a bunch of constraints. I mean, not strictly needed, but it would be cleaner to delete them. So I have this magic piece of APOC that clears the schema. There you go. And by doing that, I get rid of all the schema elements. And now we just stay with another relationship. That was a nice trick, so that I learned also this week. But like I was saying, why don't we go to another one? And
you have to show that again.
Oh yes, sure. Sorry, that was a quick one, but it's and let me show that APOC schema assert. So you can actually that helps you essentially. I can. If
I'll link to the docs. Yeah,
it helps you defining in one go a collection of constraints without having to call them one by one, and in the same way you can remove it. So it's pretty convenient. So yeah, sorry,
that is convenient. Yeah.
But I was saying that, okay, let's look at another data set. So, and I found this supply chain that I thought it might be a bit richer. I mean, it's in this case it contains 33 columns, so maybe there's potential for additional entities there. And we're going to do exactly the same process. So once we've cleared the database, I'm going to start again from my notebook. And, I'm running it in blocks here so that we can explore what's going on. But this can be run in a single go. So what I'm going to do here is, okay, I'm going to comment this dataset, which is the housing market. And we're going to go with the third one. The second one was about interesting touristic destinations in India, but I'll skip that one in the interest of time. And we'll go with supply chain example. So there you go, another pair of metadata file plus data set, which are
and that the supply chain data set, is that also what was also okay? Here you go. Okay.
Yeah. So do you have it, or shall I paste it on the chat So
I
that
think I'll find it. But if you have it quickly, yeah. Okay, perfect. Yeah, thank you. Then I'll put it in
there
there.
you go.
Yeah.
So yeah, like I said, the usual process. So we start by, okay, we're going to import the croissant file. So the croissant file, similar to the one we saw before. I mean, you can download it from here, and we have it in GitHub, so you can import it directly. Once we have it, we are immediately ready to explore it. Same structure that we had before. So the queries that we run should work again. So that was it. So we can return the subgraph. We'll have the usual problem with the visualization. Let's give it a try.
Let's try. Yeah.
Let's.
Yeah.
We're
That's
lucky.
better.
It did the coloring, but it didn't do the naming. But anyway, so we have the data set.
At least the colors. That's helpful.
Let's make it bigger. So we have the data set. The data set contains the record set, and then there's a bunch of properties grouped by data types. So, and again, it's not super readable, but these should be the 33 columns that were listed there. These are the floats. These are the dates, as you can see. These are the booleans. These are the integers. And for each one of them, we have the name of the price, pack price. We have the line item insurance USD. So that's unit price. So there's lots of columns, completely flattened. And like we did before, we're going to present that in a way that is going to make it easy for us to, I think that was it, to pass it to the LLM. So this is the dataset name, the dataset description, and the collection of features with their data types. That's what we're doing, and that's what we're going to be doing again in our code. So here we go. So we extract these elements, and we generate the prompt. So the prompt has exactly the same structure, except that now it's not the house market, it's supply chain. There's sometimes this is pretty poor. I mean, it's kind of okay, but sometimes
it's short.
you get a much richer description depending on the data set, and I let you play with Kaggle and pick your preferred ones. But what's important is we have the collection of features with the data types, right? So we have the prompt. We send it to the LLM. That's where it's going to take a few seconds. And here is where it's exploring the 33 features, the 33 columns in our CSV, and coming up with a model by uncovering or surfacing the latent kind of entities and relationships that can be extracted from it. So the moment this is done, we're going to be able to I see we're having loads of questions about the sharing the notebook. We will, of course, as soon as the session is over, you will find it in the GitHub repo for Going Meta. This is the phase that takes a bit longer. It still should only be a few seconds. And let's any questions that we can answer while this thing is going.
It takes a bit longer today.
Yeah.
There was a question on LinkedIn. Yeah,
I'm reading. Is this RAG still? That's not. This is not RAG. I mean, RAG is. Let me actually. It's done now. But it's a very, very, very important question, and let me make sure that I get back to this one, Alex. I'm going to complete the example for completeness, and then we'll get back to that. This is not RAG. This is previous to RAG. This is the construction of the knowledge graph. So we've run the generation of the model. If we explore it, there you go. So it's a bit more. It's a bit longer, more entities, but it looks at the structure is the same. Entities with the name. There's a notion of a country with a country name. There's a shipment with a scheduled delivery date, and so on and so forth. So a collection of entities. There's a notion of a product. There's a notion of an order. There's a vendor, and then there's a brand, and well, I can keep. This is a much richer one. That's very, very interesting. I'm happy that we chose this one. And then it didn't find any relationships. That's annoying.
No, that's not good.
Bad. Why? Oh, why? Let's run it one more time, because this is I mean, if it doesn't work, that's the unpredictable part. I mean, it's, you know, it doesn't make a lot of sense that it hasn't found it, but let's give it another try.
Let's try again. Yeah.
And I'll take a minute to answer what RAG is, because, and I'm going to go to the episode 24. This is RAG. So RAG is, once we have, I mean, RAG is a, if you want an architecture, a pattern, kind of a integration pattern somehow, where we're building an application that interacts with an LLM, right? So we are asking questions from an LLM, and that can be to provide a kind of a conversational interface, or it can be to do any kind of customization or generation by the LLM. Now, if we build an application that just interacts with the LLM, we rely entirely on the LLM's capabilities to generate, to reason, but also on the knowledge about the world that the LLM has, which is sometimes incomplete, as we've mentioned several times, because LLMs are trained on public data, and they will not be aware of your enterprise business data or your personal data. So we have to somehow inject that knowledge, these facts, these grounding facts, into the process. And that's what happens in this intermediate step. And that's where we augment the generation. That's why it's called retrieval augmented generation. I like to call it augmented generation, but it's based on retrieving data from an external source, a source that's curated, that's controlled, and that in our case is a knowledge graph. So what we do is, based on the task that we want to solve, that we want the LLM to work on, we're going to go out to an external source. And there's a number of ways to do that. And we've touched that on episodes 22, 23, 24. We retrieve all the potentially relevant information from this external source, a knowledge graph, and then we pass it in the context to the LLM. And then the LLM will return an answer, but grounded and based on these facts that I've passed in what's called the context. And therefore, I'm injecting this external knowledge, controlled, curated, trustable knowledge in the process. That is RAG. What we're doing now is we're constructing a knowledge graph out of, in this case, structured data. And this is kind of a different process. Let's see if this has finished. I hope that clarifies things. Let's see if that's returned now some relationships. If not, we'll have to unfortunately give up. But oh, there you go. We have no. This is relationships. We have, yeah, perfect. Now it came up with some, so that's good. So I don't know. It's like you see, it's a little bit unpredictable. It's generating stuff. So anyway, so we have some entities that have been extracted, and now we're going like we did before. I don't need to recreate this function because it's exactly the same, and it's using the same schema elements. So all I need to do is rerun, call this function, but this time, oh damn it, something has happened here. Of course, that's when type, key error type. Why there's not a type? Let's try to. So we're not having, our name is not type. Oh, data type. There we go. No, is that what we're looking at? Yeah, I think that's it.
I think it's data type. Yeah,
data type. Like, so that's, there you go. That's the reason why I did that. Is this? No, that's not what I'm looking at. Mapped to relationship name is the type. No, that's relationship name is name. So that's the thing. The relationship name is called name. I believe that's the thing. So maybe we can give it another try. Perfect. Now it looks better. And if we, so again, what I've done there is I've had to deal manually with the fact that I'm not enforcing the structure returned by the LLM. Like I said before, there's mechanisms to make sure that this returns the right JSON structure, but I didn't have time. I don't think it would fit in this session, but there's mechanisms to guarantee that. Because I did not enforce it, I have to kind of read what the output of this looks like, and it's using relationships, name, to, from, to make sure that my function consumes that output. So that's the only thing that we've done. So there you go. So we have a new set of cipher instructions that will populate the graph, And if we run this again, this will hopefully populate the graph, and now it's importing countries.
Nice.
It's importing shipments. So there you go. So these are the entities that have been extracted from these supply chain data sets. So these, as we saw before, is a flat data set with 33 columns, and it contains loads of information. So what we've asked the LLM to do is to extract a model out of it, a graph model, and that's what it's done. And it should be done shortly. It's finishing now, populating the relationships, and the moment it's done, we should be able to have a look at the let's wait till it's done. So it's item order. Good.
Yeah.
Finished. So we can now okay, we can remove this because this is because we still have in the same graph, this is the metadata description. Remember that we have the data set that contains a record set with fields, etc. But the actual model from the input looks something like this. So we have a shipment that contains items that that's used in orders, and shipments, are associated to countries. So that's the model that it came up with, and we can now explore it in the graph, right? So we can see that we have orders, and if we expand, orders will be linked to items. An item will be part of multiple orders, will also be part of multiple shipments. The shipments will be associated with countries. I can do the usual to make it look a bit nicer. But there you go. So that's where I probably stop and look at some questions. But we've come up with a decent and reasonable graph model out of entirely unstructured and flattened CSV data, and all through a fully automated process. So I hope that kind of made sense. I know in some parts I went a bit too quick, or maybe I didn't go into a lot of detail. In particular, the function that generates the cipher out of the mapping. But you can, like I say, it's just a bunch of lines. It's pretty straightforward. It iterates over the structure returned by the LLM and generates cipher out of it. So you can explore it once I share these, and that should be, like I said, relatively straightforward. But yeah, let's take a pause here, Alex, and look at some questions. If that
have some questions. I think it is remarkable in a sense also that we used two data sets that we haven't really looked at a lot in detail before, and we kind of still can work out what they mean and how it works and how it fits together. So I think that's very interesting and very nice to do and to work with.
Probably just one comment before you go ahead with the questions. In this case, and again, it was my personal curiosity. I found that there's these kind of structured description of the metadata of the file, right? These kind of JSON definition in croissant format. But again, replace that with whatever is your preference. Sometimes you may not have that description, and what you have to do is what Dan did, right? You have to maybe parse the CSV file, extract the headers, maybe do a bit of profiling. You have to try to extract some of the metadata. But the moment you have a description that you can pass to the LLM, the LLM, the more clues you give it, the better model it will come up with. If the columns come with a description, then it will probably come up with a better model. So that is available in the case of Kaggle, and I invite you all to go and check your favorite data sets, and it will generate a model out of them. But if you don't have that description, you can generate it from in other way.
Yeah. And with that, you already answered a question from Stefan, who wanted to know if this only works with structured data. But it does work with the unstructured data as well. But you probably have to do a little bit more prep work and a little bit more
Well,
I guess,
yeah.
train LLM so that the LLM knows what's going on.
Yeah, I mean, the thing is, with unstructured data, the process is slightly different, because there, what you're doing,
Yeah.
here, what we're doing is, I know what I kind of have understandable or well-defined descriptions for my columns, and I'm going to come up with a model. Now, if you have unstructured data as a paragraph or a document, the process is called entity extraction, and I think we've talked about that in other episodes, right? And there, it's more of I'm going to extract maybe entities of different types, but it's a substantially different approach, I would say.
Yeah, good point. Could you summarize what is the advantage of doing this with an LLM?
Well, it did it for us, basically. That's I mean, not doing it
That's
with
work.
an LLM means I have to be an expert. I mean, I'm not saying that what we did is rocket science, right? With some training and with just looking at our great documentation and materials, you will get best practices and guidance on how to do graph modeling. But sometimes for people, it can be a bit of a blocker. I mean, I'm used to work in Excel, but I cannot determine which things can be entities and how should I come up with a plausible graph model. Well, let's ask the LLM to do it for us, and that's the advantage, that it's done it for us without us having to know anything about graph modeling, right? So that's, again, take this with a pinch of salt. This is a fully generated model, and this will probably require iterations, right? It might not come up with a perfect model, but it will be definitely a starting point to see your data, your tabular data, in the graph without having to basically to write a single line of code.
Yeah, exactly. I think that's that's a pretty good advantage, and especially like we said in the beginning, this is not. I mean, this is an idea and a concept and a like a proof of concept almost, that it can be done, and that you get quickly to a first result. If you then decide on exploring this data set further, and if you want to then incorporate this and work with it as a graph, then you probably should step back still and have a little think about, is this actually right? Is maybe, are there mistakes in there? Is it making complete logical sense? Because the LLM is not 100% right. So they might hallucinate some stuff. They might come up with some connections that are not really the right ones and stuff like that. But I think as a general starting point to something where you might have a little bit, you are at a loss of what's actually in my data, and you just have a huge table and you don't really know what to do with that. I think this gives you a great view of hey, how do I get from there to a graph in relatively no time and relatively no writing code, and then exploring that data.
Absolutely.
Yeah. There are a couple of questions that go into this same vein of why using Neo4j, or why using a native graph database for a knowledge graph. So a couple of people asking here is, how is this better than OntoText, RD, Fox, Cambridge semantics labeled property graphs are still not semantic knowledge graphs? Or another comment here, I'm a long-time Neo4j user. There are other options for data store like Vector Store, Azure, Cosmos DB, and so on, that work as a backend for a RAG application. What are the key justifications for having a native graph database or a pure knowledge graph as the back-end data store?
Wow,
I mean,
many of them.
long question with a potentially long answer.
I'll take the one from Joe on how it is better than OntoText, RDF, Fox, Cambridge semantics, and blah blah blah. I mean, we've talked about this many times, so I would refer you to earlier episodes when we talked about the difference between RDF and property graphs. I mean, it's we're different types of stores, and this, I would say, the quick answer is we work at different levels of abstractions. Triple stores break everything down into statements, into triples, and from a storage point of view, they're a table with 3 columns. That's what a triple store is. I'm simplifying, of course. It will have indexes, etc. But basically, you work at the triple level, at the statement level. With the property graph, we work at a different level of abstraction, which we believe it's kind of nicer. It's more developer friendly, more data person friendly, because we work at the nodes and relationship level. So for us, a node is a rich structure that describes, for example, Alex. We can say that Alex and Jesus are friends. So that there's 2 nodes connected with a friendship relationship. Right? If you want to represent that as RDF, you have to decompose it basically every node will be a sequence of triples that you can put on a triple store, and the relationship will be more triples, etc. So two different ways of looking at data. I mean, different levels of abstractions. There's loads of advantages in the property graphs. We've talked about that. We put them side by side in many episodes. So I totally refer you to look at that, and that, I think that answers the question. The other one, I think you mentioned, I don't know if it's there, the vector databases. I don't think vectors play a key role in this episode, but Neo4j is a graph database with vector search enabled graph database. So we combine the two ways of exploring data, storing and doing semantic search, graph semantic search and vector search. Again, we covered that in episodes, I believe, 22, 23, 24.
Yeah.
So please go back to those, because there's high level of detail, and like I say, it was not part of today's episode.
Okay, cool. Maybe to finish today, one more question here, also all coming in via LinkedIn. Maybe going a little bit more into what you said before is if you don't have a croissant metadata text file, if you have here's somebody asking, hey, can we do it without tabular data, but for example,
Sure.
PDF text data or something? I think we showed it in a way that makes sense and was easy to showcase, but you can use more or less any other data set you have, or data format, or however the data is structured. It will take, like you said, it will take a little bit more time to prep, I guess, but technically this should work with
just
more or less.
Remember that ultimately what we do, I mean, we have this croissant format, which is super rich, but ultimately what we're doing, remember, is that, I mean, we're passing, I mean, the key thing is this portion here. I hope it's readable. So we're going to call the completions API. We're going to call the LLM and ask it, hey, build me a graph, a model out of these flat data. And what I'm passing is this prompt. So how you come up with this is entirely your choice. So I'm passing, this is my data set, this is what it contains, and this is the collection of features or columns, right? Or this is what it contains. If you can come up with this in a different way without using the croissant, and probably you can just, I mean, in pandas, if you use Python, there's loads of functions to read a CSV file and return the headers. You can even manually add annotations to add additional descriptions, but ultimately you have to, you have to pass these features in your data set to the LLM. And I choose this format. How do you come up with this format is entirely your choice. If you have the croissant, great. If you don't, there's many other ways.
Yeah. I mean, for starters, you can potentially ask an LLM to create these for you out of your file you want to send to the LLM. It might not be really, but it as a starting point, it probably could be good enough.
And it depends in a number of factors, right? So if your data is well described and it has metadata, you have like headers that are readable and meaningful, then perfect, because the LLM is going to make sense of those. Maybe sometimes data comes, look at this PQ. What the heck does PQ mean? POPLSO. So maybe by the context, it will make sense of it, ASN, DN. Maybe, but sometimes this is not great. And what you have to do is do a bit of profiling. Maybe you want to read a little bit of the data and pass that to the LLM and say, can you make sense of that? And maybe you can say, these are names, these are dates, these are, and so, and there I would, again, refer you to Dan's notebook. And I think you put it on...
it's in the video description on YouTube, yes.
It was in one of the slides, but he kind of goes into a more conversational, iterative approach. So he, parses the CSV and asks the LLM, what could I give you so that you can produce a model? So there's loads of things that can be done. I mean, we went with one approach that kind of fully automates the process, but it's not the only one. I wanted to kind of show how LLMs can help. I mean, we've talked many times about how they can deal with unstructured data to do the entity extraction. Today, I wanted to explore how they can also help in dealing with structured data, for which we don't have necessarily a rich model description.
Yeah, absolutely. Cool. I think that that brings us perfectly to the end of today's session. We thank you all for watching today. Thank you for presenting and for showcasing the demo, Jesus. That was really insightful and really, I think that should encourage lots of people to try it out yourselves. I mean, easiest way is wait for the GitHub repo to be updated and then pick your favorite Kaggle data set and give it a spin yourself and see where you go. And obviously, you can add on it, expand on it. Let us know when you do that. It's also always interesting to see how you work with the stuff we're providing here. As we said in the beginning, if you have any questions, any feedback, any comment, anything you'd like us to cover in one of the future episodes, then don't be shy. Best place, I think, is probably the YouTube comment section, but you can reach us in other channels as well. And if you are interested in what's coming up, then I can give you a short glimpse of what's happening next week. I'm having Michal Stefaniak as a guest, and he will talk about the Cypher GUI, user-friendly administration for Neo4j. That should be fun and interesting. That's happening on the 13th of February, so next Tuesday. And yeah, we'll be back in March, beginning of March, and with another topic, another session of Going Meta, episode 26. Until then, I'm wishing you all best of days. Enjoy time, enjoy the rest of your week, and yeah, see you soon. Thank you very much.
Thank you. Bye, everyone.
Bye.